And you obviously saw yesterday that when things grow, if things grow by 1% each year, that doesn't mean in 5 years it's grown by 5%, right? Does that make sense to you guys? That's kind of the idea of compounding. You make 1% the first year, but then the second year when you make your 1%, you're not making 1% on just the initial value anymore. You're making 1% on the initial value and then the little bit of gains that you had in that first year. So it actually ends up growing a little faster than just the 1% per year seems. So anyway, this is the idea of compound interest. There is a formula that you have to memorize for this one as well. There are some similarities. It is final A, or capital A, that'll be your final account value. A sub 0, again, that's your initial account value. It's not 1 plus R anymore, but it's 1 plus R over this N, and we'll talk about what N equals. And it's not just to the T power, it's to the N times T power. So R still stands for rate as a decimal. T still stands for the amount of time. What the N is the number of times it's compounded. So let me give you an example. If you were to open a bank account and it tells you that you get 12% per year, okay? That doesn't mean that you put your money in on January 1st and just let it sit there all year, and then on December 31st, they'll give you 12%. It doesn't work that way. They'll compound that 12 times, which means that 12% is split up into 12 sections. You'll get 1% in January, 1% in February, 1% in March, throughout the year, so that by the end, you've gotten your full 12%. So that example would be compounded monthly, which in other words is 12 times a year. So if you see the word monthly, that means N equals 12. If you see weekly, that means how many times in a year? 52 weeks in a year. You got a short year, Lucas. 52 weeks in a year. Yeah. There's about 4 per month, a little more than 4 per month. So 4 per month would put us at 48, and then those extra couple days every month. Yeah? Okay. Daily would be, depends on if it's a leap year, but pretending it's not, 365, and so forth. Okay, so you got to look for those trigger words to get your N value, because it's not going to tell you. It's not going to say as like N equals 12. It's going to say compounded monthly, and you have to know that N equals 12. Okay, so what it'll do is it'll split whatever your rate is into that many parts, and it will give you each part kind of separately throughout the year. All right, so a person invests $500, that's A sub 0, in an account that earns nominal yearly interest rate of 4%. So R is 0.04. Don't worry about that nominal. How much would this investment be worth in 10 years if the compounding frequency was once per year? So that would be N equals 1. And we're gonna wait this out for 10 years, so T equals 10 to see how much it's worth. So again, with these word problems, it's just reading and figuring out what numbers go in where. So our final amount we don't know. That's what they're asking us for. Our initial amount was 500. 1 plus rate was 0.04. N was 1 to the 1 times 10 power. And we're just plugging that in. 500. 1 plus 0.04 divided by 1 is kind of pointless. Raised to the 1 times 10 is just 10th power. So your $500 will have grown to $740 and 12 cents. Yeah. Sure, they're really hot in here. You can just open that one wider or that one, as long as it's not windy. So how much money did you earn? for free. Oh, yeah. Right. You pretty much got $240.12 for free. Good? I guess it's a good thing I got the door open today, because if it was closed, it would be even hotter. Okay, let's change the scenario. If, on the other hand, the interest was applied 4 times a year, known as quarterly, so what would N be? If you see the word quarterly, that's 4. We're gonna not pay attention to their question. We're just gonna find out how much would be in the account. Same scenario, starting with 500, growing by 4%, but this time it's quarterly, so your N is 4. How much would it be worth after 10 years? Do you think it would be worth more or less? We'll talk about it. It's actually worth more. The more times you compound, the better for you. So if I plug that in, 500, 1 plus 0.04 divided by 4, raised to the 40th power, 744. It's not much more, but this is only $500. If you had $100,000, that would be an extra like $4,000 for you, something like that. So the more money you have, the more of a significant change that percentage difference. And here's why. Think back to what we talked about yesterday. Go back to that monthly example. If I make 1% in January and 1% in February and 1%, and I make 1% 12 times, most people, probably including some of you still, would think, okay, by the end of the year you've made 12%. And that's wrong. You've actually made a little bit more than 12%. Because again, in February, you make the same 1% on your original amount that you invested, but you also made 1% on that little bit of interest that January provided you. And so you make a little, like even though you make 1% in January and 1% in February, you actually make more in February because your initial balance was higher, right? And then in March, your initial balance is even higher because you've got January's interest in there and February's interest in there. So you make 1% on your initial balance that you contributed, but you're also making 1% on money that the bank gave you in addition. And so you actually make a little bit more than just 1% each month, it seems, by the end of it. Okay? Without actually explaining, that's why it's not exactly the same. That's what the whole compounding concept is. If you were told that an investment earned 4% per year, how much would you assume was earned per quarter? Oh man, I don't care about that. It's just going to be more confusing than it's worth to explain. Using your answer from part C, calculate how much the investment would be. Oh, we already did that. We kind of did and talked about all these things already. The fact of the matter is to realize that 4% compounded once is different than 4% compounded 4 times. Okay? The more times you compound, the better for you, because it's more opportunities to make a percentage off of money that wasn't yours to begin with. Right? If we wait the whole year out and just give you 12% at the very end of the year, you're not making money off of anybody else's money. Right? Because that's all been yours the entire time. Versus when they split it up and give you little bits of interest each month, you're making money off of someone else's money, and that's why these things grow exponentially. Okay, number 3. For an investment with the following parameters, write a formula for the amount the investment is worth after A after T years. So the final amount is equal to, and we're just plugging in, P is the initial amount invested, 1 plus your R over N to the N times T power. I don't know why. You know what? Maybe I didn't anticipate giving you that right at the top of the page. So, whoops. We already knew that. Let's just keep using it. How much would 1,000 Invested at a nominal 2% yearly rate, compounded monthly, be worth in 20 years. So A equals A sub 0. I'm just going to copy this down. Oh, and where do you think that 1,000 is going to go? A sub 0, very good. Invested at a nominal 2% yearly rate. What am I going to do with that, Vince? So R equals what? 0.02, good. 1 plus 0.02. By the way, did you notice there's not a plus or minus here? We're going to assume that you don't sign up for a bank account that's ever going to lose money, right? This isn't really exactly the same as the stock market. This is a bank account where you know how much you're going to make. The issue is, well, why would you put it in the stock market then? Well, a bank account, you get, it's not even 1%. It's guaranteed, but it's a very tiny amount. Whereas the stock market, you could make 12%, which you'll never get in a basic savings account. You might also lose 2%, so you have to be okay with that. It can't be money that you need right away, because if you ever lose a percentage, you don't want to take it out after you've lost. You want to invest more and let it grow. That's my advice. Compounded monthly. What am I going to do with that, Sierra, with a C? What does monthly mean? N equals 12. And how much is it going to be worth in 20 years? What am I going to do with the 20, Jack B? Yeah, 12, that's your T for time. You're waiting this out 20 years. So after 20 years, 2% isn't a huge amount of growth, but we'll have more than 1,000. That's all that matters. Oh, I didn't type it in wrong. I just typed that in wrong. And I just want to see if people can tell me why. I did 1,000, parentheses, 1 plus 0.02 divided by 12, raised to the 12 times 20th power. Why did that give me the wrong answer? Georgia? You know what? Because this is in parentheses and because division comes in order of operations before addition anyway, it's actually going to do that right. You can insert another, but it's going to do that division before it adds anyway, just because it follows PEMDAS. Right. It's going to raise it to 12 because exponents come first, and then it's multiplying the whole thing by 20. So I really need my exponent in parentheses, or I can just do it in my head. 12 times 20 would be 240, right? Or if you don't want to do that, and you just keep your exponent 12 times 20 in parentheses. 1491.33. So I earned almost $500. So the nominal rate is what they tell you you're getting in the year. The effective rate is what really the compounding works out. So like I told you, if you open a bank account and it says that their rate is 12% annually, but it compounds monthly, your effective rate is probably going to be definitely going to be slightly more than 12%, right? In theory, you make 1% each month for 12 months, that's 12%. But by the end of the year, your effective rate is probably something more like 12.2%. You actually gain a little bit more because of the compounding. Okay? This one's just going to explore the same information, but look at what happens quarterly, monthly, and daily. We kind of already talked about that. This is going to be the most beneficial because that's compounding. This is only 4 times, this is only 12 times, and this is 365 times. So that's going to be, give you the biggest final balance. So so I'm gonna skip that. We kind of already made the point about the more times you compound, the better. The last thing here is continuous compound interest. So you might not compound quarterly or monthly or daily. They might say you compound continuously. So that's almost like splitting up your rate into an infinite number of parts, which is kind of a weird concept to wrap your head around. You're taking whatever your rate is, and since it's all happening continuously, which would be even more than like every second of the year, you're pretty much splitting that R up into an infinite number of sections. And you would never obviously plug in n as infinity. That would leave you in a weird spot. There's a separate equation for this that you also have to remember. Sorry, this chapter is definitely heavy on, like, there's 3 formulas you just have to know, and they're all somewhat related. They have a lot of the same initial value, ending value stuff. This one's probably the easiest to remember because I just tend to say the PERT formula. So P is your initial value times E to the R times T power. R is your rate, T is your time. So the PERT formula, anytime you see compounded continuously or continuous growth, buzzword continuous, think PERT. Okay? PERT formula. And you'll use it exactly the same. So a person invests $350. Where does the $350 go? Okay? For a capital P. Good. That promises a nominal rate of 2%. So that is what, Natalie? 0.02 equals R. Very good. You see the buzzword continuously, so obviously if this were out of context and you didn't have that formula sitting there, you'd see continuously and you'd think PERT. So write an equation for the amount that in the investment after T years. So your final amount, A of T, equals 350 times E to the 0.02 T. That's your general equation that you will use for that initial amount and that rate of growth. How much will be there after 20 years? T is 20. You're just plugging that in. So A of 20 is 350 E to the 0.02 times 20. So the amount in your account after 20 years is, and this is straight calculator work, E to the 0.02 times 20. That one, $5.22.14. C kind of phrases it differently. Using that same formula, how much time will it take for the investment to reach 400? Corey, where would the 400 go? Nope. Your principal investment is still 350. You're right. You're waiting and you're trying to figure out how long until this 350 grows to 400. And it wants you to algebraically solve for the exponent, which is what we've been doing the past few days. Divide your 350 over. To get the variable out of the exponent, we take the natural log of both sides. So the ln of 400 over 350 and the ln of E will cancel. So it'll just equal 0.02t. Divide both sides by 0.02. And t equals, calculator work, natural log of 400 divided by 350. Take that answer, divide by 0.02. It's going to take about 6.7 years. T equals 6.7 years. And the last one, bear with me if the bell rings. This wants the effective rate. The rate compounded continuously is 0.02. I'm going to do this to get the effective rate. 350 is my initial balance. If I just type in E to the 0.02 power, it's going to give me 1.02020134. So my effective rate is really a little more than 2%. Not much, but it's really 2.02%, 2.020134 if you want to get really into it. So this PERT formula, that R gives you your rate, but technically you make a little more than that. And you can see that you're 0.02 and then some over 1. Homework's coming. Oh, I didn't reflect your corrections. I'll give them out. No rush. I sent you a remind message, but I did update the flashcards. I don't remember if I put the PERT formula on there, but once I get the PERT formula on there, that's the final list. I think I did already put it on there, even though I knew we hadn't gotten to it. Float it in like very naturally, like that's where that should be. And I'm sure you don't disagree. On Friday? Yeah. Oh, okay, good.